early 70s and late 60s, the field of groundwater was really done by the USGS, and they did water flow, but not water contamination, and care of all of the groundwater issues, but not contaminated groundwater. And we were just beginning to learn how we'd lost chemicals into the groundwater, polluted major water supplies.
I did my PhD thesis with Perry McCarty, who is one of the fantastic mentors for many people in this profession. Perry was unbelievable in introducing me to the scientific aspects of environmental engineering and getting me involved in research and education. The early 1970s, Jim Luckey developed the book Better Homes and Garbage, which was really a fundamental beginning of this whole sustainability movement, and was never, I think, really appreciated and recognized for what it was. Gil Masters was involved in that book, and if you go back and look at that book, many of the foundation things that we're now trying to teach our students about sustainability were clearly included in that book.
There are several people that were very influential in allowing me to achieve what I did. First of all, foremost is my PhD advisor, Werner Stumm. He was just so influential in the way he approached things, what he taught us, what I learned from him that carried me on for the rest of my career. Charlie O'Melia, who was a colleague at the University of North Carolina before he went to Johns Hopkins. Charlie taught me a lot about process engineering, and was a great mentor. His style, the way he dealt with people, he was a very good role model for me.
When I was a senior, my two good friends in civil engineering told me about a course that they needed to take to complete their civil engineering degrees, and said, why don't you take this course? It was called environmental sanitation. Why don't you take this course? You don't need to have any mechanics background or structures and so on. So I took the course, and it exposed me to the field that then was called sanitary engineering, but has since become known as environmental engineering. That happened at a time shortly after the book Silent Spring by Rachel Carson was published. It was published in the fall of 1962. I read that book, and it made a profound impact on me. It really made me to start to think about the impacts that humans were having on, particularly on aquatic environments, but on the environment in general. The book was, of course, about the effects of persistent pesticides on ecosystems.
I think,
and
reflecting back at the University of Michigan, we were just at the cusp of making a big change in the way students went through a PhD program in what was then called sanitary engineering. It's an old-fashioned name now, sanitary engineering. Nobody refers to us as sanitary engineers. They refer to us as environmental engineers. But the idea at that time was to blend traditional topics that you have in civil engineering with those in chemical engineering. And this was a big issue for me to go to a chemical engineering department. As an undergraduate, I always thought chemical engineering I would never be because it's so difficult a topic. But going there to take courses in chemical engineering was a really watershed event for me. I think it put me in a really great position in our field because so much of those principles in chemical engineering became part of how we do business now.
Rachel Carson wrote her book, The Silent Spring, in 1965, and I was in high school then, getting ready to graduate. And that book kind of struck me as to what was happening in our environment. Everybody was beginning to pay attention to it at that point. Not now. We started paying attention to the environment a long time ago. And also in my household, being raised, again, like I said, in the segregated South, the men who collected the garbage and trash were, the garbage men, but because they were black, we were never allowed to call them garbage men in the house. So we decided as little girls and all, so our parents wouldn't get upset with us, we called them the sanitary engineers. So every Thursday night, get the trash out for the sanitary engineers and all. So one day when I was a senior in college, I was walking by the bulletin board in the admin building and saw this sign that said scholarships in sanitary engineering. And at that time, it wasn't environmental, it was sanitary. And I said, scholarships for master's degrees in sanitary engineering. They have to be kidding me. What is that? So I read, and I said, oh my goodness, this is what I'm really interested in. It's the science, it's the math, and of course it was the environment.
The Clean Water Act was just 1 month old when I went back for my PhD. And basically the Clean Water Act said you can't poison the fish. But there wasn't anything in the Clean Water Act that said you couldn't take all their water. So that's basically the sort of problem we had in the West, is sort of taking all the water. And you say, now, wait a minute, in the future we're not going to do that. We have to provide water for ecosystems. Attitudes have changed. It's the right thing to do. But what does that mean? It means it's just it's another big challenge. In fact, in California, it's the biggest challenge that we face in the state. Of how do we meet the freshwater needs for ecosystems while still providing that for agriculture and for urban areas?
I served on various committees and boards of the National Research Council, which is a component of the National Academies, and it advises the government in terms of policy. My main effort was to come up with regulations and policies that allowed industry to be economically attractive as well as environmentally safe. So for that effort, one of the societies, CTAC, Society of Environmental Toxicology and Chemistry, they awarded me a career award, the Rachel Carson Award, which for an industrial person to win the Rachel Carson Award was a surprising thing.
My thesis topic at Harvard University dealt with the elimination of a problem that had arisen recently after the war, namely the appearance of detergents in waterways and streams that were receiving discharges from wastewater treatment plants. These foams that were forming on the top of the water bodies were attributable to sulfonated alkyl benzenes, and they were in detergents. And my thesis topic focused on how to remove those, because they were not removed in traditional wastewater treatment processes, and so they did end up in streams and waterways. I focused on a variety of means for removing sulfonated alkyl benzenes from water, but principally on the utilization of activated carbon to adsorb them.
Having grown up on the west side of Chicago, and Chicago is home to some of the greatest architecture in the world, so I decided early on I wanted to be a civil engineer. And that interest was really increased tremendously because they were building the first expressway in Chicago right in front of my house. So I thought, this is exciting. So as a kid, I got to go out there and play on the equipment. I got to watch literally my neighbors' houses being moved out of the right-of-way, and this was all very exciting, heavy stuff. And so that really reinforced why I wanted to be a civil engineer. After the construction was finished, I now found that my house was the entrance to the ramp to the Eisenhower Expressway, and we had traffic, noise, air pollution day and night. And I began to think, well, maybe this isn't such a good idea, especially if you have to live next to it the rest of your life.
My undergraduate work was at Northeastern University in Boston, which is a co-op school, and I did a variety of jobs in co-op, but the one that really clicked was when I was working in Claire Sawyer's laboratory at Metcalf and Eddy doing water analyses, and it got me interested in the environmental field. And then Bob Meserve, who was a professor at Northeastern, was the one that really got me enthused about the field. And then I'd say the third person, or the third activity, was someone who was not even associated with me in some respects. I was applying for graduate school and started talking with Bruce Haynes at Tufts University. And Bruce kind of convinced me that I should go to a major university to get a PhD. And I did, and that's what got me into the field.
In the early days, back in the 50s, I guess, that's early for me anyway, our educational program was determined by the American Society of Civil Engineers. And let's face it, the environment's a lot broader than that. And so we I think I worked with Fred Poland, who was a member of this group also, another professor. And we figured out that what you needed to do is work closely with the American Academy of Environmental Engineers, and when you worked with them, they could become a sponsor of ABET, which is the accrediting agency and who determines the criteria for our programs. And so I became involved in that end of it also. And the fact is, I actually prepared the application for the Academy, AAEE, to become the accrediting agency for environmental engineering professors, so that we had an input by our members that served with the American Academy on their education committee. And I considered it a challenge to get that thing to work. The reason I really got interested in environmental engineering is, I guess, the time I spent working with the Board of Health in Montana, and I looked at the problems that were associated with that, and I said, you know, I really want to help people, and there are health problems. And again, back in the 50s and 60s, the major thrust of the environmental field was health and people. It's interesting, if you ever wondered where the water standards came from, drinking water standards, they really originated because of the then modern mode of transportation, which was a train across our country. And drinking water standards were needed because trains would stop at all these little towns and pick up water, and people would get sick because the water didn't have any uniformity. And so that was the thing that attracted me to the environment in the first place, was the interest in trying to help people really survive, because I know there's a lot of interest in extinct animals and plants that have become extinct, and really I got involved in the environment because I didn't want people to be extinct, because I kind of like people. And that was a major thing that attracted me to the field, was trying to work with people and help people. And sometimes, I shouldn't say this, I guess, but I think sometimes we kind of lose sight of that and the other things that we find ourselves working with.